Welcome to Myth Busting. I'm Bucket.
I'm Brella.
I'm Courtney.
And I'm Gnome.
Today we are going to be debunking some common myths about physics.
Okay. Myth number 1. Newton's second law states that for every action there is an equal and opposite reaction.
However, some people think Newton is a liar.
In this lab, we will show what happens when one person exerts a force on another person. Materials needed, one skateboard. Why did Sam move, but Isao did not? To answer this question, we are going to reverse the roles.
Pusher becomes pushy.
Both equal and opposite forces were exerted. However, in the first example, when Isao pushed Sam, Sam has a low friction because of the skateboard, while Isao has high friction because he is rooted to the ground.
So what happens with the force? Does it just get pushed into the earth?
Yes, it does.
In the second example, equal and opposite forces were again exerted on both Isao and Sam. But since Sam, the pusher, was now on the object with very low friction, the skateboard, he was the one affected by the responding opposite force and was thus pushed this way, while Isao stayed in the same place because his feet are still firmly rooted to the ground.
Myth confirmed. Unless you're talking about the myth where Newton's a liar, in which case that one is busted. Myth 2.
Myth: horizontal and vertical velocities are dependent.
To test this theory, we will be throwing one ball directly horizontally and seeing if it lands on the ground at the same time as a ball dropped straight without being thrown to the side.
Crazy. Even though one was thrown and one was dropped, they landed at the same time. Why is that?
This is because gravity exerts a force on both of them that is independent of their horizontal motion. Therefore, they accelerate towards the earth at the same rate.
Myth busted.
Myth number 3. Forces exerted at an angle to an axis do not depend on length.
To test this, Sam will exert force at different lengths from the axis to try and lift William up.
First, I will exert a force close to the axis of rotation.
He can't do it.
Next, I will exert a force far from the axis of rotation.
Whoa, that worked.
Myth busted. Length does matter.
Myth number 4. This myth states that the cross-sectional area of a tube in which a fluid is flowing and the velocity that the fluid travels through that tube with which are not related.
I have my doubts about that one.
Here is what I call A1V1. We got this area right here and a nice moderate velocity of water. Now what happens when I make A1 and make it A2? Oh, you got this smaller area and a nice strong little pump here of water. What does that mean?
This clearly demonstrates that there's an inverse relationship between the cross-sectional area of a tube and the velocity of the water.
Myth number 5. Energy is not conserved. You can get free energy.
I'm gonna drop a ball and see how high it bounces back up. Naughty?
So, why didn't it bounce all the way back up to where you dropped it?
Well, as you can hear, some of the energy is lost to sound, and the ball's quite warm. Some of it's also lost in the form of heat.
At its start point, the ball had a lot of potential energy due to its height above the ground as well as the force of gravity. As it fell, that force was converted into kinetic energy. And as it bounced and came back up, it returned into more potential energy. However, due to the losses we explained earlier, it did not get back to the same energy level.
Myth busted. You can't get free energy. Also, the same principle explains why perpetual motions cannot exist in our real world, where energy is always lost through heat and sound emissions,
And friction.
as well as friction.
Okay, thanks for coming. That was it.
We busted a lot of myths today. None of them were true.
But sometimes the biggest myth you've got to bust is your own heart. Until next time. Let me say something.
Bye.